For this exercise on exception handling, we're actually not going to do any exception handling. Instead, I'm going to show you ways to write code so that exceptions won't be thrown. So we're going to get started by opening a program we'll call except.ex1.py. We're going to start with the divide by zero exception, zero division error, that we saw earlier. What I'm doing right now is I'm writing a function that simulates a very simple calculator. So bear with me while I write this code. You'll see what it does. It's very simple. And then finally, we have division. So that's the function. Now what we're going to do is write a program that uses a loop and continuously asks the user to enter another equation to compute. So we're going to have a while loop that prompts the user to enter a number. And this will be an integer calculator, just to keep things simple. Then we'll ask them to enter the second number. Then we'll ask them to enter the operation. Again, the problem that can come up is if the user enters a 0 for the denominator in a division statement or in a division problem. So we can test for that by saying if the operator is equal to slash and the second number is equal to 0, then we're going to say cannot divide by 0. And then right here, we're going to issue a continue statement, which will cause the program to go back to the top of the loop and start over again. Now that's probably carrying it a bit too far. We really only need to have the second number, but we can't really get to that point without using a go-to statement, which we're not going to even talk about. So we have to just go back to the top of the loop. Otherwise, we'll call the calc function with the 3 arguments. All right, so let's save and run the program, see if it works. So we'll enter a 3 and a 2, and we'll do multiplication, and that worked fine. So now let's do a division. 12 and 0, and division. And it says cannot divide by 0. Enter the first number, enter the second number, enter the operation, and there we go. Now, one thing we left out, and let's fix that real quick, is we left out the prompt to ask the user if they want to continue. And that's all we need. I'm not going to add that into the program because you saw how it worked. So that's our first example of how we can write our code to protect against an exception being thrown. This makes your code easier to read, easier to understand, and easier to maintain. Let's comment out all this code. This is easier than starting a new file. Our second example is going to demonstrate how to work with file handling. So what we're going to do is we're going to write a simple program that opens files and prints the contents. So we ask the user to enter a file name to open. Following the same strategy as the previous program, we're going to use a special function called isFile. And it's actually found in os.path.isFile. And what this does is, this snippet of code right here will check to see if a file exists. And so what we're saying is if the file does not exist, then we're going to print an error message, and then we're going to prompt the user to enter the file again and continue on. Otherwise, or once the user does enter a legal file name, we're going to open the file, and then we're going to print out each line, just like so. So again, the key is saying while the file does not exist, and that's this part of the code right there. Then we prompt the user, first telling them that the file doesn't exist, and then to enter the file name again. All right, so let's run this example. Let's clear the screen. So let's try one that we know doesn't exist. Blah.txt. File does not exist. Enter file name to open. Blah1.txt. Oh, that's not it. bbbb.txt. That's not it. But I happen to know that we do have a file called grades.txt. And then when it finds it, it opens it up and displays the contents. So in this exercise, I've demonstrated ways to actually not have to use exception handling, and most programming experts would say that for problems such as the ones we've looked at, dividing by zero and files not existing, using what I would call data validation techniques works better than using exception handling. And with that, we're finished with this exercise, and that wraps up this chapter.